Hello, hello. Hello, my name is Connie, and today I'm going to be going through an example of monad transformers and how you can use them to reduce boilerplate and combine the effects of different monads in your code. So a little bit about myself. I'm on the data platform team at Twilio. We build and maintain all the data pipeline infrastructure, so a lot of data ingestion from other teams, and we expose that data to allow other teams to consume it. And we use a lot of Scala-related technologies like Kafka and Spark, and we have a lot of services in Scala. My journey with Scala started around 3 years ago. I started learning about Scala and functional programming, and I got really into writing very pure functions and reducing error handling in my code and writing just very straightforward business logic. And I learned about monads and applicatives and functors. I'd heard of monad transformers, but it sounded very intimidating, and I didn't really look much into it. But as I learned more about them, I realized they're very useful for just improving my day-to-day code and using them in my general programming. So what are monad transformers? Well, they basically allow you to combine different monads and combine their effects to create like a super monad. For example, if you have a future that allows you to model an asynchronous operation, and you have an option that allows you to have the presence of something or not, you can combine them to have a future of option. Likewise, you can also have like a future of either, where the either effect is two different types, or you can have like a reader T, where the reader, it should be reader of option, where the reader, lets you do dependency injection or something. So in this example, I'm going to use the cats library, and this is just a library that contains a lot of functional programming things, and yeah. So first, a little syntax. So if you have something like a future of either of A or B, when you use the monad transformer, you will be using the either T monad transformer. And the syntax would be either T of future A, B. And likewise, when you have a future of option of A, you would use the option T monad transformer, and that gives you a future of A. Option T, future of A. So it's kind of switched, which makes it a little intuitive, but yeah, just remember the monad transformer is usually the one that's inside. So in this example, we're going to be making some coffee, because I like coffee. And our first step, we want to grind up some coffee beans. And I'm really into coffee, so you'll know that you want to grind up the beans immediately before you start making coffee, because you don't want that pre-ground stuff. And then that keeps the beans fresh. So let's define some imports and case classes. So we have general imports, a case class for your input and output, and then maybe we have like some exception that occurs when we try to grind the beans. So this is our first function, grind fresh beans. So we take the input beans, we're returning as output future of option of grounds, and we have this Boolean that models an asynchronous operation, maybe that it's failing. So if you can see the function, you'll have 3 different outcomes. So if perhaps the operation fails, we get a future failed of the exception. And otherwise, we want to check if the beans are fresh. And if they are fresh, then we return a future of successful of option of grounds. And if not, then we return a future of successful of none. And this is kind of a common scenario that I encounter on my team as we write a lot of asynchronous microservices, because sometimes when we make a call to a downstream service via HTTP, we don't we want to distinguish between the two error cases of if the operation failed versus if we made the request and we didn't really find what we were looking for. So in that case, we would return the future of successful of none. And if the operation failed, you might return the future failed. So this method kind of has 3 different outcomes. 1 success scenario, which is the value is found, and 2 failure scenarios. 1 is value not found, and 1 is future failed. So we kind of want to distinguish between those scenarios. So our second step, we want to boil hot water. And you can see this is very similar to the first step. We're defining an input, output, and a case class for coffee, which is our end result, and then an exception. So here's the function for getting hot water. It looks very similar to the first method in that we're also returning a future of option of water. And again, we have a Boolean that models the asynchronous operation failed with the exception. And so we have 3 cases. If the asynchronous operation fails, we return a future of failed of hot water exception. Otherwise, if the kettle is filled, we return our success scenario, which is a future of successful of option of water. And otherwise, we return the future of successful of none. So now let's combine our steps 1 and 2 to make the coffee. So this one's pretty straightforward. You just take the inputs, grounds, and water, and then we just return a future of successful of our case class coffee. So first, let's look at what our code might look like without monad transformers. So we have 3 steps. We can model this as a for comprehension, and then print out some log lines on the output. So our first step was grinding fresh beans, and this is a success scenario. So let's set the fresh equals true, and then second step is to get hot water. And then now, since we're getting from those methods a future of option of some type, we want to unwrap those options. And if the options are none, then we want to throw an exception. So here we unwrap and throw the exception because in our making coffee method, we're not handling the option, so we want to handle the option before that. So this is what it looks like with the success. Without monad transformers. So let's look at what happens when we execute it. So pretty straightforward. We get a future of option of coffee. We get the log line that prints out, and we get a success coffee case class. So with monad transformers, this is what our code looked like before without. And with monad transformers, this is what it looks like now. It looks very similar to the one before, but a little shorter. And basically all we're doing is wrapping option T over the methods. So grind fresh beans, get hot water, making coffee, and then we wrap an option T around it. And the rest of it looks pretty much the same. So let's see what happens. Cool. So it's basically, you're getting basically the same result, successful coffee making. And the type is now an option T of future coffee. So let's go over some helper functions now. So if you noticed previously in my for comprehension, I was using liftf. And what liftf basically does is just gives you an option T from the future. So our type that we wanted was an option T of future of A, and because our last method was returning a future of coffee, we want to lift that into the option T type. So likewise, we also have a from option type, and then that gives you an option T from option. So you can see you don't necessarily need the future of option type to construct the option T monad transformer. You can just use these helper functions. And internally, they're just wrapping in the monad's success scenario and yeah, giving it back to you. So now let's look at a failure case, which is a little more interesting. So if you recall our first step, grinding fresh beans, if we set the Boolean equals false, then that will give us a future of successful of none. So this is without monad transformers. We have to do the unwrapping of the options. And let's see what that returns to you. And that gives you back the exception that was present in this for comprehension. So the beans result errored. So in the for comprehension, we had to unwrap the option and throw an exception to trigger the short circuiting of the for comprehension. So with monad transformers, let's see what happens. Again, we're setting fresh equals false, and we have the code that we had just now. So now we get back an option T type, but this time because of the future of successful of none, because of the none failure scenario, we get the no coffee found log line that was coming out of the error handling back here. So instead of having to unwrap the option results ourselves and throw the exception, the monad transformer allows us to just short circuit the for comprehension on a none. So another failure scenario, this time we get the exception. So if you remember in get hot water, when we set the clumsy Boolean equals true, maybe our operation failed, maybe we spilled the water, and so we get a future of failed of exception. So let's see what happens when we execute this one. Cool, we get the hot water exception that was coming from the method. So now we're getting back a future failed of exception, and that's also coming from that method, and this just short circuits the for comprehension. And so from these examples, you can kind of see that with the monad transformer, the future of option is being treated as one monad, and depending on the semantics of the monad, the for comprehension will short circuit on the error scenario. In this case, it's a future failed or a none, and so that we didn't have to do it ourselves. So what did we learn from this example? You can use monad transformers to short circuit your monads, like we showed on a future failed case or a none. And instead of unwrapping the layers of monads ourselves, we can use the monad transformer, and that gives us a new monad to work with, and then we don't have to do the unwrapping ourselves. Yeah, and that just reduces a lot of layers of map, future.map, option.map, and to just one map. And that helps reduce a lot of boilerplate in your code because you don't have to write out all the layers. So what's next? If you're interested, there are many other kinds of monad transformers, like reader T, writer T, either T, and state T. And they all combine the effects of whatever that monad is with your monad type. And since monad transformers give you a monad as a result, you can also stack those on top of each other. And that gets pretty complicated. I haven't looked into it. And that's it. Thank you.
ありがとうございました。質疑応答1人ぐらいいけると思うんですけれども、どなたか質問がある方はいらっしゃいますでしょうか。No question? じゃあマイクのところでお願いします。
Thank you. Thank you for a good presentation. I have one question. I'd like to know, I'd like to know, please show me the without monad transformation pattern, the code of the scenario. Can I see? Without monad transformation. Transformer. Yes. Yes. Thank you. That code have two exception code: bean without error and water without errors. But with monad transformers, there are no exception at that part, option T. So how can I write this kind of exception with option T?
So we did have exceptions with the monad transformers, but the exceptions were in our methods. So that method was coming from that exception was coming from this method. So with monad transformers, this exception gets thrown because it's a error type of the future. Without monad transformers, you have to throw your own exception when you encounter a none. So when we throw the exception without monad transformers in that example, the error scenario is not the exception scenario in this case. It's the future of successful of none. So we're basically handling the two different scenarios, right? Yeah. Does that answer your question?
So the problem is the pattern of none.
Yeah.
When the pattern none, without monad transformer, that code recognize which is the which error we can recognize which pattern is the error.
This pattern?
So sorry. So this code we can recognize bean without or water without after the execution, but monad transformer pattern cannot recognize the failure. Only returns none.
Right. So the monad transformer allows you to eliminate the unwrapping of the result, right?
So can I check the
Sorry,
these
I don't.
patterns? So sorry.
すみません、ちょっと時間の方が、してますので、またセッション終わった後捕まえていただいて続きの質問をしていただくということでよろしくお願いします。
Thank you very much.
コニーさんありがとうございました。Thank you very much. 拍手でお送りください。